Hello and welcome for another video about concurrency. So this is just the basics, so I will teach you in this video how to do simple parallel executions. So if you enjoyed the video, like and subscribe. So if you learned something, let me know in the comments, and if you want more basics, let me know, and if you already knew about it, that's good for you. Enjoy the video. Alright, to start with, I just want to log the duration of the execution of my main program. So we will create a simple function called start. We will print start, and then we will return time.now. So very simple. We can try it out. So if I execute that program, you can see start, and we are returning time.now, but for now we are not doing anything with it. So let's create the end function. So end will take the start time, which is a time.time. It won't return anything. We will log end, and then with start time we can calculate the duration. So the duration will be time.now when the end function is invoked minus the start time, which will give you the duration of the whole program. We can convert that time duration into string, and then we can simply log it. So we can use formatting function. So we will print the full duration, and it's going to be a string, so percentage string, and then the duration. Okay, so we can try that out. So start is returning the start time. Your end function needs the start time. So if we execute that, you can see start, end, and then the full duration of the program. Okay, so if I put a time.sleep just for a sanity check, if I put it to sleep for 1 second, so you can see start 1 second, and then 1 second and something because of overhead or execution or little overhead. Okay, so now we are fully controlling the duration and logging it. So now let's simply start with non-concurrent execution. So if I create a slice of string and a range of it, so it's a slice of string with 10 elements. So for instance, for each element, if we, for instance, we can wait, we put a sleep, but this time we will sleep for 200 milliseconds, for instance, not a full second. And then we can timestamp it. So at what time did that execution happen? So to timestamp, we will use time.now, and then the start time that we declared line 9. Then we convert that duration into string, and then we can simply log it. So using a formatting function, timestamp, and then we can log each for each item in timestamp, what was the timestamp. So timestamp, yeah. Okay, so if we can try that simple loop, so no parallel execution whatsoever, and you can see that one by one it got executed after 2 milliseconds. So you can see overall is 2 seconds because 200 times 10. So all good. So we will clean a bit. So we will extract that little execution in the loop to make it a function. So we will send to that function the index of the loop and the start time, so then we can calculate the timestamp. Yeah, simple as that. So timestamp is the name of the function, so we will just rename it as t, and I is now the index. Okay, we can still try that out to see if we haven't broken anything. So timestamp I and then the start time. If you try that out, can see it gives relatively the same result. So it's still 2 seconds because you're doing it one after another in that loop. So you can imagine those are costly operations, so you want 10 expensive operations. So then if you don't parallelize them, it would take you 2 seconds to do them all. So now a simple introduction to goroutines. So with the keyword go, you can simply create another process during the execution of your program, and this little routine will execute in the background. So it would be a good idea to just simply go over the loop and spawn 10 routines, but as you can see, nothing happened really. What happened there? It's just that you have a slip in that timestamp function, and so then your routine just got executed, but nothing was waiting for it. So then your main program just finishes without waiting for your goroutines. So here on line 20, I'm introducing a wait group. So a wait group will allow you to orchestrate parallel executions. So that's the key of the video today. So with a wait group, so I'm declaring one line 20, so then you can add workers to it by using the function add. So here we're adding one worker each time we go through the loop. So then we are registering worker. So we can start it, and you can see that it's still not doing what we want. So the thing is, you're registering it, but you're not telling to your parallel execution that the job is done, that your parallel execution is done. So first step is you register the worker. So you're gonna register 10 times. Then here I'm just doing a little bit of cleanup. So instead of invoking directly the function timestamp directly, I'm just wrapping it in another anonymous function. So then you can see line 28, I'm using the keyword done. So then I'm telling the wait group that parallel execution is done. So if you don't remember what differ does, have a look to the video about it. But it's still not doing what we want. So we're missing a third last step, and it's the waiting step. So basically we're telling the waiting group to wait for all the parallel executions to finish, and then the main program can resume. Yes? And there you go, the magic. So you got 10 parallel executions there, and the full duration is 200 milliseconds instead of 2 seconds. So the 10 goroutine line 26, they are happening at the same time. So here I just wanted to show you another way to register workers. So you can simply just register the 10 of them straight away by using the length of the timestamp slice, and it's still working as intended. So to summarize, 3 steps: registration, telling the execution is done, and then waiting for them to all being done. Here I just want to catch your attention about something dodgy. Like you can see 9s are appearing multiple times as opposed to the parallel one. So the non-parallel one is just 0, 1, 2, 3, 4, 5, 6, 7, and so on. But our parallel one is just doing multiple time 9s or other numbers. So this is due to the fact that when you're using a loop, a for loop, I is in fact a pointer shared across the body, and your routine is in the body of the for loop. So to fix that, I just need to copy the value of that pointer, and you can see that now the timestamp function, the routine, is using a copy of that value and not modifying the pointer. So that's very important if you're in a for loop or you're looping in something in Go and using the parallel execution, because you might have some nasty mutable surprises. There you go. So you can see that now they're all randomly happening and finishing at the random time, basically roughly 200 milliseconds. But you can see that the sixth happened first, and then the third, and then the first, and so on and so on. All right. So to summarize again, so this is the very basics of concurrency in Go. So 3 steps. So registering your workers, then inside your working routine, declare that you're done, and then lastly, make your waiting group wait for all the parallel execution to finish. Okay, so I hope you enjoyed that very short video about concurrency. I invite you to do it again yourself on your spare time, so just don't look at what I've done and just try to parallelize little tasks by yourself by using slices of int or string or manipulating string like that, so then you get the gist of it. So it's a little bit tricky. It's not it's like a recipe really. Just remember the 3 steps and it should be fine, but I invite you to practice yourself so then you can master it. Also, another little homework that you could do is to try testing a function or a service which is using parallelization in Go. You might find some pitfalls, you might find tricky to do it, but it's a good exercise. Hope you enjoyed the video, and as usual, happy coding everyone.